Okay, welcome to 7.1, example one, where we start to actually look at some graphs of exponential functions. So the first one we're going to look at in A here is y equals 4 to the power of x. Like most things, it is hugely beneficial to look at a table of values, which we conveniently have here. Keep in mind that we are putting the number 4 to each of these x exponents. Now, some students struggle with the fact that, 4 to the power of negative 2 is 1/16th. But remember, a negative exponent indicates that that would go into the denominator, and 4 squared is 16. So that's where that 1/16th comes from. Once you have those, and you could certainly just, put this into your calculator, right? There's nothing wrong with that. But what we get is this particular function. And I'll just move some of the stuff that are up there. So they're just grabbing, and you could have made this or grabbed this off your calculator with, putting y equals 4 to the x in, and then just hitting trace and putting in several different x values. Couple important things about this graph, just kind of working through what they ask us to do. X is an element of the real. There's no value of x that causes us to take, the square root of a negative, divide by 0, or later in chapter 8, a negative logarithm. That doesn't happen. So that is our domain. X can be any real number, but y can't. Because y is the output, and although it is difficult to see, I'm going to draw the dotted line, badly, I suppose, down here. It does have a horizontal asymptote at y equals 0. So it approaches 0, but never actually reaches it. So y must be greater than 0. But other than that, it's any real number within that range. Okay, x-intercept and y-intercept. Keep in mind that x-intercepts are where y is equal to 0. So we would be looking to solve this. 0 is equal to 4 to the power of x. But we just finished saying that 4 to the power of x is always greater than 0. So there is no x-intercepts. Y-intercepts are a little bit easier. Y-intercepts are where x is equal to 0. So that is equal to y is equal to 4 to the power of 0. Anything to the power of 0 is 1. So my y-intercept would be at the point 0, 1. You can just say it has a y-intercept of 1, but I always do like writing out, the actual coordinate for that. Okay, it says whether the graph represents an increasing or a decreasing function. As x goes to the right, my function does go up, so it is increasing. And I'll just write that over here as kind of a summary. It is an increasing function. You do not have to do more, and I'm just going to write in here that the c, the base of my exponential function, is greater than 1. That means that it's an increasing exponential function. Okay, pretty straightforward. Hopefully, a lot of this is just making sure you're comfortable, maybe putting this into your calculator and finding several values off of it. We're going to do B as well. I just got to find it here. The table of values never hurts to do. We do see kind of the opposite behavior here, is that if x is a negative number, it would be 1 over 1/2 to the power of 3, and that ends up being 8 instead. Remember, you can get these values off your calculator, although your calculator is not going to give you 1/2. It's going to give you 0.5 and 0.25, right? Your calculator does like those decimal values. All right, so without further ado, we'll put that into, I'm going to reveal it, but using our calculator, we would see this. Now, that bracket is very, very important. And I think maybe I would like to show you kind of a common mistake that I have seen students do. Your calculator blindly follows whatever we tell it to do. So if I were to type in, okay, I want 1 divided by 2, and then that's going to go to the power of x, your calculator reads this as 1 divided by 2, and only the 2 is to the power of x. So it's very important that we put the base of our exponential function in its own bracket. And although that seems like a subtle difference, that makes all the difference in the world. And this is something that is really pretty consistent across courses, is that when you have a fraction within a more complicated expression, put that fraction in a bracket so your calculator recognizes that for what it is. Okay, looking at this graph, as x goes to the right, y goes down, so it is decreasing. And I'm going to write that right away. So it's a decreasing graph. And I will put that means the base is greater than 0, but less than 1, and 1/2 is certainly within that range. The domain is still all real numbers. The range is still y is greater than 0 and all real numbers. There is still no x-intercept, and the y-intercept is located at 0, 1. You are going to see a lot of maybe familiarity between these functions. There's one thing I forgot, sorry. It does also have a horizontal asymptote at y equals 0. That's identical, except for the decreasing part for the first question. And that's something that we're going to talk about again and again and again, that whether we're talking about increasing or decreasing, if it's a basic exponential function, then it shares those properties. And these are things that I don't know if memorization is ever really the best technique, but that is very, very consistent for basic exponential functions. Now, the one thing that I'd like to, show, and we're not going to do it today in the notes, but I'm just going to highlight that in the blue graph. Let's think about all the chapter 1 stuff we've done. What if I took that blue graph and I vertically translated it up? Well, now I'm drastically changing, the range of that function, but not the domain. If I moved it left and right, I wouldn't actually change the domain either because it's all real numbers. We certainly have a lot of different transformations. The biggest one I want to talk about is what if I vertically translated it down? And what we would see happening is that now we would have an x-intercept. So the one thing I want to caution you about is don't fall into the pitfall of saying that no exponential functions ever have x-intercepts, because that's not true. No basic exponential functions have x-intercepts, but as soon as we start vertically translating these, we really have to understand that that can create, or at least, cause an x-intercept to occur.